What if I told you there's a fighter jet so advanced that it can literally become invisible to enemy radar, shoot down targets before they even know it's there, and perform maneuvers that seem to defy physics? Well, that aircraft exists, and it's been dominating the sky since 2005. But here's the thing, there are only 187 of them in existence, and the story of why that number will never increase is more shocking than you might think. For decades, air combat was a game of who could fly faster, turn tighter, and spot the enemy first. But by the 1980s, military strategists realized a terrifying truth. Traditional fighter jets were becoming sitting ducks. Enemy radar systems were getting so sophisticated that even the most advanced A-15s and F-16s could be detected from hundreds of miles away. The problem was clear. In future conflicts, whoever got detected first would likely die first. The US Air Force needed something revolutionary, something that could rewrite the rules of aerial warfare entirely. Think about it. Imagine being a pilot knowing that the moment you take off, every enemy radar operator within 200 miles knows exactly where you are. Your speed, your altitude, your heading, everything exposed. You're not hunting, you're being hunted. And in a world where surface-to-air missiles can travel at Mach 3, being detected isn't just disadvantageous, it's a death sentence. This wasn't just about losing dogfights anymore. This was about losing entire air campaigns before they even began. The stakes couldn't have been higher. Enter the F-22 Raptor, the world's first fifth-generation fighter that would completely transform everything we thought we knew about air combat. But what makes this $377 million aircraft so special that it's still considered untouchable nearly 2 decades after its first flight? And more importantly, why did the US government make the controversial decision to stop building them forever? The answers will surprise you. Let me ask you something. What if you could make a 65-foot-long fighter jet appear no bigger than a steel marble on enemy radar? Sounds impossible, right? Well, that's exactly what the F-22's stealth technology achieves. The Raptor's radar cross-section has been reduced to just 0.0001 to 0.001 square meters. To put that in perspective, a conventional fighter like an F-15 appears on radar like a pickup truck. The F-22? It's virtually a ghost. But here's where it gets really interesting, and this is something most people don't know about stealth technology. The F-22's stealth isn't just about special coatings, though those are important. It's about geometric perfection. Every surface, every angle, every curve has been precisely calculated to redirect radar waves away from their source. Those angular surfaces you see, they're not for show. They're radar deflectors operating on principles of physics that would make Einstein proud. The serpentine air intakes are particularly ingenious. They prevent enemy radar from getting a direct line of sight to the engine components, which would light up like Christmas trees on radar screens. It's like designing a maze that radio waves can enter but never escape from. But there's a weakness to this stealth technology that enemies have discovered, and it's more concerning than the Pentagon would like to admit. Here's the thing about F-22 stealth. It's optimized for high-frequency radars, the type typically used by fighter jets and modern missile systems. But there's an older technology that can spot it. Long-wave VHF and UHF radars operating with wavelengths of 1 to 10 meters. These systems can detect the F-22 at ranges exceeding 150 kilometers, though thankfully with limited precision. It's like being able to see a ghost but not being able to aim at it. Still, this vulnerability has forced F-22 pilots to adapt their tactics, flying at high altitudes and using specific approach geometries to minimize detection angles. Now, being invisible is one thing, but what good is a ghost if it can't see its enemies? This is where the F-22's sensor systems become absolutely mind-blowing. At the heart of the Raptor is the ANAPG-77V1 ESA radar, and when I tell you the specifications of this system, you'll understand why enemies fear it so much. Picture this, 1,956 individual transmit and receive modules, each roughly the size of a stick of gum, working together to create a radar beam that can be steered in tens of nanoseconds. That's faster than you can blink. This system can detect enemy aircraft at ranges exceeding 320 miles, while maintaining its own low radar signature. But here's what makes it truly revolutionary. It's not just a radar, it's an information fusion system that combines radar data with communications, navigation, identification, and electronic warfare systems simultaneously. The pilot doesn't see separate displays for each system. They see one unified tactical picture that would make science fiction writers jealous. and the electronic warfare capabilities. The F-22 can reportedly fry the electronics of enemy sensors. Imagine flying a fighter jet that can blind its enemies with the push of a button. But wait until you hear about the engines that power this technological marvel. Most people think speed in aerial combat means afterburners, those dramatic flames shooting out the back of fighter jets. But afterburners have a problem. They're basically giant flares saying "here I am" to every heat-seeking missile in the area. The F-22 solved this problem in the most elegant way possible. Those twin Pratt and Whitney F119 engines produce over 35,000 pounds of thrust each, enabling something called Supercruise, sustained supersonic flight without afterburners. The F-22 can cruise at Mach 1.8 while staying relatively invisible to infrared sensors. Think about the tactical implications. You can engage enemies, fire your missiles, and be gone before they even realize they're under attack. It's like having a sniper rifle that shoots across entire states. But the real magic happens when those engines start moving. Remember those impossible maneuvers I mentioned earlier? They're made possible by two-dimensional thrust vectoring nozzles that can pivot plus or minus 20 degrees in the pitch axis. These nozzles are controlled by the flight computer and require no input from the pilot. The result, the F-22 can maintain controlled flight at angles of attack exceeding 60 degrees, where conventional fighters would stall and fall out of the sky. We're talking about maneuvers like Pugachev's Cobra and sustained post-stall flight that look like they belong in a video game, not reality. With a thrust-to-weight ratio of 1.25, this aircraft can literally accelerate straight up. Imagine dogfighting an opponent who can suddenly stop mid-air, rotate on its axis, and fire back at you. It's like bringing a gun to a knife fight, except the gun can also do backflips. But here's something that might shock you about how these incredible capabilities are actually used in combat. Now, you might think that with all this stealth technology, designers would want to hang weapons all over the F-22's wings like a Christmas tree, but that would defeat the entire purpose, wouldn't it? External weapons create massive radar signatures, so how do you arm the world's most advanced fighter jet without compromising its invisibility? The answer lies in 4 internal weapons bays hidden within the F-22's fuselage, 2 main center bays and 2 side bays, each precisely engineered to carry specific weapon loads while maintaining that marble-sized radar signature. For air-to-air missions, the F-22 carries 6 AIM-120C AMRAAM missiles in the main bays and 2 AIM-9 Sidewinder missiles in the side bays. But here's the incredible part, those main bay launchers eject missiles at over 25 feet per second with 40 G acceleration. That's enough force to knock a grown man unconscious, but precisely controlled enough to ensure perfect missile separation even during high G maneuvers. The engineering challenges were immense. How do you open weapons bay doors at supersonic speeds without destroying the aircraft? How do you launch missiles while rolling at 100 degrees per second? The solutions required innovations that pushed the boundaries of aerospace engineering. But the F-22 isn't just an air-to-air fighter. For ground attack missions, those same bays can carry 2 1,000-pound GBU-32 JDAM bombs, or up to 8 small-diameter bombs alongside its air-to-air missiles. The aircraft literally wraps its aerodynamic design around these internal bay structures, making the weapon system integral to the plane's very existence. And this is where we need to talk about one of the F-22's most controversial aspects, the human element. Building the world's most advanced fighter jet is one thing. Finding pilots capable of operating it, that's an entirely different challenge. F-22 pilots don't just fly aircraft. They manage information systems that would overwhelm most computer operators. The training pipeline is so rigorous that it fundamentally changes how we think about pilot skills. Traditional fighter pilots operated individual systems, radar, communications, navigation, weapons. F-22 pilots must think like information managers, synthesize data from multiple sources simultaneously while making split-second life and death decisions. The training utilizes ground-based training systems and live virtual constructive technology that can simulate complex threat scenarios without the massive resource requirements of live training. But even with advanced simulators, the transition from 4th generation to 5th generation thinking represents one of the biggest challenges in military aviation. These pilots have pioneered 5th generation tactics that emphasize stealth employment, sensor management, and networked operations, concepts that have been directly transferred to F-35 training programs and will influence fighter pilot training for decades to come. But here's where things get problematic, and it's an issue that threatens the entire F-22 program. Now, I need to tell you about the F-22's dirty little secret, a problem so severe that it threatens to ground the entire fleet if not properly managed. Remember that marble-sized radar signature I mentioned? It depends entirely on specialized radar-absorbing coatings that are incredibly difficult to maintain. These coatings degrade in high-flow areas, and when they do, the F-22 becomes visible to enemy radar. The maintenance requirements are staggering. Traditional methods required 1,600 hours of labor per aircraft just for inlet duct refurbishment. That's like having 8 mechanics work full-time for an entire month on a single plane. The Air Force had to develop maintenance robots, actual robots, to handle stealth coating restoration. These aerobotic systems reduced labor requirements to 300 hours per aircraft, an 80% improvement that has saved approximately $8.8 million since 2016. But the problems run deeper than just coatings. Here's a statistic that should concern everyone. F-22 mission-capable rates fell from 73% in 2014 to 60% in 2016, with stealth coating issues being a major contributing factor. For missions requiring full stealth characteristics, the mission-capable rate ranges from just 62 to 70%. Think about that. The world's most advanced fighter jet is available for combat missions only about 2/3 of the time. Combat damage or environmental factors can require repairs, costing approximately 150,000 euros per incident. The Air Force has implemented usage-based lifing programs that utilize real-time data to optimize maintenance schedules, and they're testing chrome-like surface coatings to improve resistance against infrared tracking systems. But these are expensive band-aids on a fundamental design challenge, and this leads us to perhaps the most controversial decision in modern military aviation history. Here's where the F-22 story takes a dramatic turn that shocked the aviation world and continues to generate controversy today. In 2009, Congress made a decision that military analysts still debate. They terminated F-22 production at just 187 aircraft. The total program cost $74 billion. That's approximately $377 million per aircraft, making the F-22 one of the most expensive fighter jets ever built. Why would you stop building the world's most advanced fighter? The official reason was prioritization of immediate war requirements over long-term strategic needs. The F-35 Lightning II was seen as a more versatile, cost-effective solution for multiple military branches and allied nations. But this decision created consequences that we're still dealing with today. With no production line available, spare parts availability has become a critical issue. When something breaks on an F-22, there's no factory churning out replacement components. Every repair becomes an expensive, time-consuming challenge that affects readiness rates. The Government Accountability Office has warned against premature retirements without adequate replacement planning. The Air Force is planning to retire 32 Block 20 F-22s to fund modernization of the remaining aircraft, but this reduces the already small fleet even further. Yet despite these challenges, the F-22 has proven its worth in ways that might surprise you. For years, critics argued that the F-22 was a Cold War relic designed for threats that no longer existed. Then combat operations began, and those critics fell silent. The F-22 made its combat debut in September 2014 during Operation Inherent Resolve against Islamic State targets in Syria. But this wasn't just about dropping bombs. It was about demonstrating capabilities that fourth-generation fighters simply couldn't match. The F-22's stealth allowed operations within sophisticated integrated air defense systems that would have been suicide missions for conventional fighters. Syrian, Iranian, and Russian aircraft altered their flight patterns simply because F-22s were in the area. That's the power of technological superiority. Sometimes you don't even need to fire a shot. The F-22's first official air-to-air kill came in February 2023, and it was unlike any engagement in aviation history. The target? A Chinese surveillance balloon floating at over 60,000 feet off the coast of South Carolina. The F-22 climbed to 58,000 feet and fired an AIM-9X Sidewinder missile at a target above 60,000 feet, demonstrating precision engagement capabilities at extreme altitudes that no other fighter could match. Additional balloon intercepts in Alaska further validated the system's unique capabilities, but perhaps the most impressive demonstration of F-22 dominance came during training exercises. During Exercise Northern Edge 2006, F-22s achieved a kill ratio that redefined what air superiority means: 108-0 against F-15, F-16, and F-18 adversaries in realistic combat scenarios. Let me repeat that: 108-0. Over the entire exercise period, F-22-led formations achieved a 241-2 kill ratio, with the 2 losses being F-15Cs operating in support roles, not the Raptors themselves. The aircraft maintained a 97% mission capability rate during the exercise, proving that when properly maintained, the F-22 is virtually unstoppable in air-to-air combat, but the F-22's influence extends far beyond its own combat record. The F-22 didn't just change air combat, it revolutionized an entire generation of military aviation technology. Much of the technology developed for the F-22's APG-77 radar was directly applied to the ANAPG-81 radar system in the F-35 Lightning II, but the relationship works both ways. F-35 radar improvements are being incorporated back into F-22 upgrades. The programs share common sensor fusion principles and stealth design approaches, though adapted for different operational requirements. F-22 operations pioneered 5th-generation tactics, including signature management, sensor fusion utilization, and networked operations that are now standard across all advanced fighter programs. F-35 production benefited enormously from F-22 manufacturing experience, particularly in stealth coating application and composite materials handling. The F-22's maintenance challenges directly informed F-35 support system design, leading to more robust and maintainable stealth characteristics. But the most exciting development is how F-22 technology is shaping the future of air combat. Here's something that might blow your mind. The F-22 is currently serving as a test platform for 6th-generation fighter technologies. The relationship between the F-22 and the next-generation air dominance NGAD program represents bidirectional technology transfer. F-22s are flight testing advanced sensors and systems under development for NGAD, while the recently designated F-47 NGAD fighter incorporates 2 decades of F-22 lessons learned. Despite being nearly 2 decades old, the F-22 continues receiving upgrades, including a $1 billion contract with RTX Raytheon for sensor enhancements, and increment 3.2 billion software upgrades, adding electronic attack capability and advanced weapons integration. The F-22 introduced the first look, first shot, first kill doctrine that redefined air combat. Its deployments serve as powerful deterrents. Russian aircraft literally alter their behavior when F-22s are in the area. The aircraft established the template for modern air dominance that continues influencing fighter development worldwide. The F-22 Raptor has remained essentially unchallenged in air-to-air combat for nearly 2 decades. Despite maintenance challenges and the controversial decision to limit production to just 187 aircraft, it successfully demonstrated 5th-generation fighter concepts while serving as a technology catalyst for the F-35 and NGAD programs. With plans to retire 32 older F-22s to fund modernization, the operational fleet continues shrinking. This creates a strategic dilemma. The F-22 represents both the pinnacle of American aerospace achievement and a cautionary tale about prioritizing short-term costs over long-term strategic requirements. The question isn't whether the F-22 was worth its enormous cost. It's whether America can afford to be without the technological edge it represents. What do you think? Strategic mistake or necessary prioritization? Let me know in the comments, and subscribe for more deep dives into military technology.